Hello everyone and welcome to Frogs, Fleas, and Painted Cubes 2.1. This will begin on page 24 of your textbooks. As we can see here, our learning target today is that I will be able to write equations of quadratic relationships and compare the relationships. One of the equations we should have come up with back in Investigation 1 through our observations is the one I have written up here, where we have area, and we know traditionally that area equals length times width. So if I have a part that says area and it equals length, then what I have left over here that it is being multiplied by is another way to express width. And the way we're doing that is we were in investigation 1, we were given perimeter a bunch of the time, and so a way to figure out the width is to take the full perimeter, divide it by 2, or what we're really doing is taking half of the perimeter, so perimeter divided by 2 minus length, and that is going to give you what your width is. And so that's the type of equations that we want to be able to write with these quadratic relationships, and then being able to compare those relationships. Our ACES questions for 2.1 here are just numbers 1 and 55. So if we turn to page 24 in our book, we're going to begin here by talking about trading land and representing areas of rectangles. And in this problem, you're going to test several cases and record your data in a table, and the table will hopefully help you to see patterns and will tell you more about situations like these. So to get started, to talk about fair trade, since we're talking about trading land here, to talk about fair trade, suppose you give a friend 2 $1 bills and your friend gives you 8 quarters. Well, would you consider this a fair trade? Now, take out the things about weight and whether you don't like coins jingling in your pocket or whatever else, but as far as value goes, is this a fair trade? Is 2 $1 bills a fair trade for 8 25-cent pieces or 8 quarters? Obviously, it's the same value, so it should be considered a fair trade. Well, our problem here, we're going to be looking at a land trade, and as it says here, sometimes it's not this easy to determine whether a trade is fair. Consider the following situation. So a developer has purchased all the land on a mall site except for one square lot. One square lot. The lot measures 125 meters on each side, as we show here, and in exchange for the lot, the developer offers its owner a lot on another site. And the plan for this lot is shown below. And this would be the lot that they offered on another site that's 175 meters by 75 meters. And it asks us, do you think this is a fair trade, and why or why not? So how could you compare these two different lots? What's a good way to compare them mathematically to be able to tell us whether this is a fair trade? So I want you to pause the film, do that calculation, and be able to tell us why or why not this is or isn't a fair trade. So go ahead and pause the film here. So as we look at page 26 and we begin with our problem 2.1 part A, it says suppose you trade a square lot for a rectangular lot. The length of the rectangular lot is 2 meters greater than the side length of the square lot, and the width is 2 meters less. Get this to go away. So A1 says copy and complete the table. And I'll have handouts for you to be able to complete this table here. So our original square, it tells us what the side length is, and we go 2, 3, 4, 5, 6, and n. And then we calculate our area here. Obviously, we need to be able to determine what our other side lengths are to calculate, well, sorry, I was looking at that wrong. We calculate our area based off of the original square, and then we do our adjustments for the length 2 meters greater and the width 2 meters less. We record those here and then calculate the area, and we're going to compare that area to this area and record the differences here in the table. Then part 2 asks us to explain why the table starts with a side length of 2 meters rather than 0 or 1. What's the reasoning there? Please elaborate on that. And then 3, for each side length, tell how the areas of the new and original lots compare. So On side length of 2, how do these two areas compare? On side length of 3, how do these two areas compare? And again, we should start to see some patterns here, and be able to determine if there is a fair trade for any of these side lengths where our rectangle is different with the 2 meters greater for length and 2 meters less for width. Part B, write an equation for this relationship between side length n and the area A1. So on the bottom part here, it has a side length of n, and you can still fill out these areas down here, as well as the area by following your same mathematical rules for calculating area. So come up with an equation for the original square, and then come up for an equation for the area of 2 at length n. So you can do both of those from the table. And then Carl claims there are two different expressions for the area of the new lot. Is this possible? And he explains. So is there more than one way to write that expression? And if you think back to investigation 1 on our ACEs problems where we had to do distributive property and apply that, you might consider that here in part B3. C1 on the calculator, I want you to sketch graphs on the same axis of the area equations for both lots. You should be able to do that. If you have questions on how to do that on the calculator, when you come to class, ask me and I'll show you how you can set that up. It wants you to do it for independent variable values from -10 to 10 and dependent from -10 to 30. Tell which parts of the graph make sense for the situation and describe any similarities and differences in the two graphs. So observe the graph, discuss it with your teammates, and try to determine what patterns you see and what parts make sense and which parts don't. That's as far as we need to go. We don't need to worry about D right now. If you want to take a look at D, you sure can, but not necessary. So those are the problem questions you should be going over with your team. Hopefully you go through them prior to class and you're prepared to discuss them with your team. Again, the ACEs for 2.1, frogs, fleas, and painted cubes, is number 1 and number 55. So I look forward to diving further into our quadratic functions with this investigation, and I'm looking forward to hearing what your questions are when you come to class. Thank you.